All right, let's get into it. Today we are breaking down a legendary tech rivalry, one that really shaped the entire world of big data. We're talking about the epic battle between Cassandra and HBase.
And that right there, that's the key to this whole story. This was never just a fight about which database had better performance benchmarks. No. This was a battle over core beliefs, about how data systems should fundamentally work. So, let's dive in.
Okay, so let's set the stage a little. It's the early 2010s, and suddenly there's this absolute tidal wave of data. We're talking about everything: social media posts, clicks, sensor data, you name it. It was this chaotic, unstructured flood, and the old-school databases, they just weren't built for this. They were creaking at the seams. This was a brand new kind of problem.
And out of this chaos, two major solutions step into the ring. Each one was born from one of the biggest tech powerhouses of the time. They both made the same promise: to tame this data explosion. But, as you're about to see, they planned on doing it in radically different ways.
You know, what's so fascinating here is you can really see their DNA. On one side, you've got Cassandra, forged in the fires of Facebook to power their massive inbox search, and on the other, you have HBase, which grew up right in the heart of the powerful Hadoop community, designed to work perfectly with all its data processing tools. Two different parents, two very different children.
And this is where the story gets really good. See, they didn't just have different lines of code. They had fundamentally different, totally conflicting philosophies about how a database should act when things get tough. This goes way deeper than just a technical disagreement. It was really about their values.
At the absolute heart of this rivalry is something called the CAP theorem. It's this fundamental rule in computer science. And to put it simply, it says when you build a system that's spread out across a ton of different machines, you just can't have it all. You're forced to make a choice between three things: being perfectly consistent, always being available, or tolerating network partitions. You have to pick two.
And here's the kicker. Cassandra and HBase made opposite choices. Cassandra basically said, we choose availability. Its whole guiding principle was always on. It would rather serve up slightly old data than not answer at all. But HBase, it went the other way. It chose consistency. Its philosophy was strict consistency. It would rather make you wait to make absolutely sure that the data you get back is the latest, most up-to-date version, period.
This forced every developer, every company out there, to ask themselves a really practical question. What do we actually care about more? Is it more important for our service to be up and running 100% of the time, even with a few tiny inconsistencies? Or is it absolutely critical that every single piece of data is perfectly accurate every time? All of a sudden, this academic idea became a multi-million-dollar business decision.
So, how did this all shake out in the real world? Well, these philosophical differences meant that each database started to conquer completely different arenas. You started to see these two philosophies carve out their own territories based on who adopted them and why.
And man, this chart just lays it all out, doesn't it? Cassandra's always-on attitude was a perfect match for huge global services like Netflix or Uber. For them, downtime is death. A user would much rather see a slightly delayed watch history than a big red error message. But for the folks in finance or telecom using HBase, strict accuracy was completely non-negotiable. You just can't have a bank balance that isn't perfectly 100% consistent. And of course, the ecosystems that grew up around them totally reflected these different paths. Cassandra, with its super flexible, no single point of failure design, was just a natural fit for the modern cloud world, easy to scale all over the globe. HBase, on the other hand, really found its home deep inside existing Hadoop clusters. It became the default choice for any company that was already heavily invested in that whole ecosystem. So in the end, this big battle, it didn't really produce one clear winner who took home the prize. Instead, what came out of this rivalry was actually a lesson, an incredibly valuable one, for the entire tech industry.
And really, this is the big lesson here. The industry matured. Developers learned to stop asking which database is faster, and they started asking the right question. Which database's philosophy actually matches the problem I'm trying to solve? The whole conversation shifted from raw performance to strategic alignment.
And their legacy is just profound. That whole abstract academic debate between availability and consistency, it became a real-world business strategy. Cassandra became the poster child for high availability at a massive scale.
HBase became the gold standard for strict consistency in the big data world, and their conflict proved without a doubt that the ideas and the values behind the code matter just as much as the code itself.
And that really says it all, doesn't it? This whole historic rivalry was never just about which technology was better. It was about what each one stood for, that unwavering commitment to being always on versus the absolute guarantee of being strictly correct. The CAP theorem literally came to life, and because of this battle, the world of big data was changed forever.